guys, in this video we're going to have a look at really the last part of this trig work that we need to do, which is really what the assessment is really going to be all about, and it's pulling together the stuff that we've been doing on trig graphs and solving trig equations. Okay, so what is this about? Okay, what we're going to quite often have is a written description of some situation, and we need to find the sine or cosine function that mathematically fits that situation, and we call that modeling the situation. Now, I did say it could either be a sine or cosine, so which one will it be? Well, it can be either. You might recall that a sine graph and cosine graph look very similar, and that one can be put on top of the other by a horizontal. Remember, horizontal is in this direction. Okay, so a horizontal shift. So when I say that we can find the equation, there are going to be at least two answers to the modeling equation. And which one do you use? Well, it's entirely up to you. But the approach I'm going to take is that we can always model this written description with a sine function. So I'm going to tend to do it in that way, except in some situations where if we've got the curve in front of us and we're trying to find the equation of the curve, it might be easier to find the cosine one first. Okay, so what are we going to need to find then? Well, you might recall that a general trig equation fits this pattern. A was the amplitude, B affected the period, C affected a horizontal shift, and D affected a vertical shift. So I'm going to find them in this order. Get A, B, and D, come back to C, because it's a little bit tricky to find, but not too bad really. Okay, so let's get A for a start. So here we're trying to figure out the amplitude. Okay, so what I can see from this graph is if I look at the topmost point, that corresponds to a y value here of 5. In fact, for this situation, let's actually try and describe it in a more of a realistic way. Let's say that instead of y, this was the height maybe of a tide being measured at a wharf, maybe from midnight, which is 0 hour, and this here, our x-axis, isn't really x, it's time in hours. So we're trying to model the tide that's being recorded here, okay, for a period of 12 hours by the looks of it. Okay, so the amplitude of our tide, the height of the tide. Okay, so the highest tide was 5. The minimum tide, the low tide, was 1 meter above the wharf, below the wharf, and this was 5 meters below. Okay, so what would the amplitude be? Well, we could just say, well, it looks like if I take the middle, it's about there. So I'm sort of going to do it sort of by intuition. That looks like the middle line to me. So this looks like the amplitude, and that's from 3 to 5, so it must be 2. And yes, that's absolutely correct, and you can do it in that way. But that's pretty good if you've got the the graph in front of you. What happens if you've only got a written description where they said the max height was 5 and the min height was 1? Well, what you might appreciate is that you could have taken the difference between the maximum and the minimum and divided by 2, and that gives 4 over 2, and certainly enough 2. So A, in a general way, we can take the max y value here, height, subtract the minimum and divide that by 2. That's a more general way of doing it. Okay, let's move over to B here. You might recall that B affected the period of a sine or cosine graph in this way. around, where the period was equal to 2 pi divided by b. Now if we turn that simple equation around a little bit and make b the subject, okay, so instead of divided by b, let's move b to the side. So we've got b times the period equals 2 pi. So b would equal 2 pi then divided by the period. Now remember, this would be true for sine or cosine. Okay, so in this particular case then, what would that equal? If I just change to a different color here, how do I get the period? Well, quite often what you're told is that, hey, the minimum tide occurred after a certain period of time, and the maximum, in this case, tide, in fact it would be a minimum, right? But anyway, let's just go with the graph look here. So that maximum on the graph occurred after 5.5 hours, and notice that's half the period from there to there. And that's equal to 3, so therefore the period would be 2 times that 3, which is 6 hours in this case. So recall again, if you're told that the minimum occurred at a certain, in this case, time, and the maximum occurred at a certain time, that is going to be half the period. So the complete period would be twice that. So coming back over here and doing our calculation, this b would therefore equal 2 pi over 6, simplifies to pi over 3. Okay, moving on, let's go and have a look at the value of d. Right, just try and put that over here somewhere. We've got a bit of room. Now you can see that the shift up has been 3. That's pretty obvious from even when we discussed how to get the amplitude. Okay, so you can do it intuitively like that, but once again, if you are only given a written description and not the graph, what would you do? Well, you might be able to see here that that 3 is really the average of the 5 and 1. By average I mean the mean value. So if you were to add together the 5 and the 1 and take the simple average of that, you end up with 3, which definitely is that vertical movement up then. And so d can always be found in a general way by averaging the max and min y values. Okay, so we're pretty close to getting our complete equation. We've got a, b, and d. Now what about c? Well, I'm just going to swap to a different color here. Now since I'm using a sine function, let me just sort of go across here from the baseline until I can see a sine sort of portion starting to begin. Well, that's certainly occurring about here, and so this from there on, okay, certainly looks like a sine curve. So it looks like the sine graph has been shifted all the way across 4 units, in this case 4 hours if we use the units along the x-axis here. Okay, it looks like so c would be equal to 4. So how do we actually calculate that once again from the written description? Well, what you might be able to appreciate is that, look at that maximum, okay, which is occurring here at that 5.5, and this here is a quarter of the period. Will that always be true? Yes. Okay, so from the maximum back to the start will always be a quarter of the period. So if I wanted to calculate c in this case, I could say c would equal 5.5 minus a quarter of the period. We know that 6 is the period, we calculated that before, and if we calculate that then, I don't know why I'm dividing it by anything, I'm not meant to be, so let me just redo that. So 5.5 minus a quarter of the period. Okay, so 5.5. What's a quarter of 6? Okay, well, it's 6 over 4. That's the same as 3 over 2. That's the same as 1.5. So sure enough, if I calculate that, that is going to be equal to 4. But this was a shift to the right. So in fact, this here should be the negative, because when we put that into that equation, if we put positive 4, then the shift would have been 4 to the left. Remember what we did on the graph work. Okay, so I actually need to put minus 4 here. So C here is equal to the negative of the time to max minus a quarter times the period. Okay, and that's a general way that you can remember what to do to get C. Okay, so let's see if we do have another color. Yellow, not so well, we might go with yellow here. Okay, so let's see if we can write a, oh, yellow's horrible, can't even see it at all. Okay, let's go with, what don't we use a lot of? Blue. So y equals a 2 sine b was equal to pi over 3 bracket x minus 4. So notice this minus goes straight into there, and then plus d, which was 3. Okay, so one way to test that would be if I put the equation in and notice that that's a sort of yellowy browny color, and if I type in the equation again here in a way that makes sense to Graphmatica, hopefully we'll see another graph going on top of that, changing that color. So what's our equation again? 2 sine. Now for Graphmatica I need to put the pi over 3 in its own pair of brackets, and then the x minus 4 in its own pair, and then a pair of brackets around that as well. Okay, and then plus, what's the case here, 3. Okay, so let's press enter. Okay, unfortunately it's exactly the same color, so, but hopefully you did see that that went on top of itself. Okay, let me see, maybe if I were to clear things out. Okay, let's clear that out and put it back in. Okay, sure enough, you might see that that is in fact matching up with all the points we were talking about. So that is definitely the correct equation. Okay, we'll discuss this further with some examples tomorrow. We'll get you guys to work on some examples for a start of trying to find this kind of equation from some graphs, and then let's take some written descriptions and see if we can find the equation of the function that models that written description.